Hello. So coming to the last part of quantitative analysis, and that is the Kjeldahls method for estimation of nitrogen. We have already gone through for the estimation of carbon, hydrogen, and then your sulfur, halogens, phosphorus. Now the biggest one, maybe somebody can call it the hardest one amongst the estimation part, because it involves the volumetric calculations. Excuse me. It involves the volumetric calculations a little bit. That is why, and the sheer size of the calculations and the sheer size of the Kjeldahls method in the book makes it much more difficult for the students to read it, because at this moment, while the exams for class 11 is coming very fast towards you, I understand to see a big page experiment, and after that calculations are based on that makes it much more difficult for you guys. So I have tried to make this Kjeldahls method estimation in a pretty precise manner, in the way that we have did in our class for volumetric calculations and some basic concepts of chemistry. So I have made this one in the same line, so that nothing goes out of the box and nothing comes extra into your mind. It is absolutely just mole concept problem coupled with volumetric calculation, that is molarity, normality and molality. That's it. Nothing else. Okay, so do not get afraid of it. First thing you have to remember, if we just revise a little bit on the halogen part, in halogen what were the precipitates that were getting formed, and we estimated based on that what is the amount of chlorine, bromine or iodine. In case of chlorides it was AgCl, in case of iodides it was AgI, and in case of bromides it was AgBr, right? Now in case of sulfur we have got something else, it was BaSO4, remember? Okay, so similarly in case of Kjeldahls method, where we are basically estimating the nitrogen part, so here the compound that is going to get evolved or precipitated is ammonia. Okay, in every problem of Kjeldahls method the ammonia will be common. This ammonia part is common, and you have to anyway estimate, either the ammonia part will be given, or you have to estimate the amount of ammonia that has evolved. And remember, 17 gram of ammonia has 14 gram of nitrogen. So whatever grams of ammonia has been evolved, whatever grams of nitrogen will be calculated, and then you can find out the percentage. So I have taken one problem. This problem is from KL Chugh. First example is a very nice problem, that is why I have chosen it. The solution though given by KL Chugh, it seems that Mr. Chugh has copied from somebody else, and I guess I shouldn't say this, but I guess it was completely copied. So he basically just copied it. If he would have done it by himself, then he would have done it in a separate way, and it would have been much more easily understandable. Anyways, not blaming anybody, Chugh has done a great job bringing out a great book in front of us. So I have made this problem in certain kind of steps, as you can see over here, 1, 2, 3, 4, 5, 6, and it's over. So these 6 steps are very important, and it is very easy, not hard. So first of all, let us go into the problem and understand it. 0.4 ग्राम ऑफ ऑर्गेनिक कंपाउंड को आपने Kjeldahls मेथड में डाल दिया. कुछ है Kjeldahls मेथड, अब भूल जाओ. अभी एक्सपेरिमेंट तो याद नहीं रखना है आपको, क्योंकि एक्सपेरिमेंट तो नहीं आने वाला है, आने वाला है प्रॉब्लम. तो Kjeldahls मेथड में 0.4 ग्राम डाल दिया हमने. एमोनिया कुछ निकला, सम अमाउंट ऑफ एमोनिया इज इवॉल्व्ड. नाउ हाउ मच आई डोंट नो. ओके, नाउ दिस एमोनिया इवॉल्व्ड इज एब्सॉर्ब्ड इन 50 मिलीलीटर M/4 H2SO4. नाइस, एब्सॉर्ब किया, मतलब whatever ammonia is evolved is absorbed in H2SO4, and the concentration and the volume of the H2SO4 is given to us. So now after that what happens, this is excess H2SO4 that is given, ठीक है, so that all the ammonia gets absorbed. Now there will be some residual acid after absorbing all the ammonia. That residual acid is diluted into 150 ml. What does this mean? आपके पास कुछ एसिड रह गया, आपने उसके अंदर और एक बोतल पानी डाल दिया, डिस्टिल वाटर डालना है, डाल दिया आपने, you make it 150 milliliter. Okay, that is what is done, nothing else. So whatever H2SO4 acid was remaining after getting absorbed, after absorbing the NH3, there will be some excess H2SO4 that is now diluted to 150 milliliter. हो गया? Okay. Now this solution 150 milliliter and some molar, whatever molar is it, H2SO4 का जो solution है, from that solution 20 milliliter of diluted solution requires 31 milliliter of M by 20 NaOH. Now, why this step is done? Now, there is some excess H2SO4. Now, I have to determine what is this excess H2SO4. How much of this excess H2SO4 is there? How many moles of excess H2SO4 is still remaining? So, to do that, I titrate that H2SO4 with NaOH. Okay, and while titration, I found out that 20 milliliter of that solution requires 31 milliliter of M by 20 NaOH. And after that, I have to find out the percentage of nitrogen. See, this kind of problems you have to always do by backward integration. So, let us see what happened in the last step. In the last step, there was some 20 milliliter of diluted what solution? H2SO4 solution. That is titrated against 31 milliliter of M by 20 NaOH. So, see, in case of NaOH, I know the molarity, I know the volume. In case of this diluted solution, I know the volume, I do not know the molarity. So, I have to find out the molarity. So, as I have done in basic concept and volumetric calculation, we have already done one thing. We have remembered to use only normality and we will forget molarity to avoid any sort of conflict and make the problem pretty easy. That we have already discussed in volumetric analysis. So, what I will do is this M by 20 NaOH is also M by 20 NaOH because NaOH जो है that is basically monoacidic. ओके सो इसका इक्विवेलेंट वेट और मॉलिक्यूलर वेट में कोई डिफरेंस तो है नहीं, तो नॉर्मलिटी एंड मोलरिटी ऑफ NaOH इज ऑलवेज द सेम. ठीक है, नॉर्मलिटी एंड मोलरिटी ऑफ NaOH इज ऑलवेज द सेम. So this will help us a lot. If you see, this will help us a lot. Okay, we'll see how it helps us, but it will definitely help us a lot. Now from here I can find out what is the milli equivalent of NaOH by multiplying these two. Correct? So milli. You can find out the milli equivalent of NaOH. Next, from this milli equivalent of NaOH, how much H2SO4 is required to neutralize this milli equivalent of NaOH? So, milli equivalence reacts in 1:1 always because reactions happens in equivalence. So, 31 by 20 milli equivalent of NaOH will require 31 by 20 milli equivalent of H2SO4. So now this diluted solution has the same amount of milli equivalent as NaOH. So I have got the milli equivalent of this diluted solution now. Now what is the milliliter of that solution I have used? 20 milliliter. Now from milli equivalent, how do I calculate the normality? By dividing by volume in milliliter. So I have just divided this by volume in milliliters. So I have got the normality. Because if you see, normality plus into milliliter, we got milli equivalent. So milli equivalent divided by milliliter will get normality. Okay? समझ में आया? चलो. Next. Excuse me. So normality of H2SO4 diluted is available to me. Now, this is the 20 milliliter solution whose normality is 31 by 400. Now this normality is for total 150 milliliter solution. I have taken 20 milliliter for my experiment purposes, that is okay. But total volume is 150 milliliter H2SO4. So 31 by 400 normal, 150 milliliter H2SO4. So now we calculate the milli equivalent of H2SO4. 31 into 150 divided by 400. Simple multiplication, you get the milli equivalent of H2SO4. Next, number 4, if you see, the steps are done. 3 steps are done. Now you know what is the milli equivalent of H2SO4 that was excess. Now we have to find out what was the milli equivalent of H2SO4 that was used during absorption. See, 50 milliliter is known to you, M by 4 is known to you. You want milli equivalents, not millimoles. You have calculated everything in milli equivalents. Now there is no point of going again into moles, right? So what I will do is, I will change this molarity into normality. How to change molarity to normality? Simply by multiplication of n factor. ठीक है? नॉर्मलिटी हमेशा मोलारिटी से ज्यादा होगा या नहीं तो इक्वल टू होगा। तो H2SO4 क्या है, डाई एसिडिक बेस है, इसका इक्विवेलेंट वेट और एन फैक्टर, पहले एन फैक्टर पता कर लो, इसका जो एन फैक्टर है वो क्या होगा, दिस इज ए डाई बेसिक एसिड, सो 2 होगा एन फैक्टर, सो एन फैक्टर से मल्टीप्लाई कर दो मोलारिटी को, आगे आपका नॉर्मलिटी वाला वैल्यू, ठीक है। तो मैंने मल्टीप्लाई कर दिया, m/4 को 2 से मल्टीप्लाई कर दिया। तो ये जो आया 25, दिस इज बेसिकली मिली इक्विवेलेंट। Now this amount of milli equivalent was used, and what was excess? This. So this was used and this was excess. Okay, this was original and this was excess. So what amount has reacted? Original minus excess has reacted. So original minus excess has reacted, and I found out what is the milli equivalent of H2SO4 that is used up or reacted is original minus excess, 13.36. Okay, 13.36. Now 13.36 milli equivalent of H2SO4. Now how much NH3 has reacted? Now suddenly I have written 3 millimoles. Why? गलत है, बहुत बड़ा गलती नहीं, गलती नहीं है। See, H2SO4 milli equivalent में निकला, so for this much amount of milli equivalent of H2SO4, how much amount of milli equivalent of NH3 is reacted? Same, because reactions happen in equivalence. So NH3 reacted is 13.36 milli equivalents. Now for NH3 is NH4 OH you can take. So that is again monoacidic base. उसके लिए मिली इक्विवेलेंट जो मोनोएसिडिक जो होता है और मोनोबेसिक जो होता है उसके लिए मिली इक्विवेलेंट जो है मिलीमोल्स भी वही है। So NH3 reacted is 13.36 millimoles, which is 13.36 divided by 1000 moles. Now this amount of moles of NH3 will contain same moles of N, right? Same moles of N, because 1 mole of NH3 has 1 mole of N. इतना moles of NH3 will have इतना moles of N. Now from moles to weight, how will you go? Multiply with the atomic weight of nitrogen, 14 gram, you will get 0.187 gram of nitrogen over here. And if you divide this 0.187 divided by this 0.4 gram, you will get around 46-47%, which will match with your answer given in the book. So this is how we did this problem. I hope that it is clear. एंड जेलर्स में आपको और कोई प्रॉब्लम नहीं आएगा। थैंक यू वेरी मच।